Okay, so we've got to the last thing that we need to revise. So let's just look at algebraic fractions as normal fractions, and then you just apply your algebra rules. Okay, so all you need to do is you need to factorize, and then we take out common factors the same as you would do if you had a normal fraction. You'd say, I've got 2 over 6, well they both divide by 2, so therefore I'm going to cancel it down. You do exactly the same thing with algebraic fractions, except that we're not cancelling down just numbers, we're cancelling down actual parts of the expression, which are the same in the numerator and the denominator of the fraction. So all I'm going to do for this part is I'm just going to cover a few examples and what you do in different situations. Just remember that when you've got times or divide, I can times and divide the numerator and denominators of each fraction together, and I cancel across numerator and denominator, right? So if it's equal something in the numerator and something in the denominator, then you cancel them down. Likewise, if I've got adding or subtracting, all I'm looking for is to make the denominator the same, and then I multiply through the numerator however I've changed the denominator of the fraction, so that it's still an equivalent fraction, however it has a shared denominator with another fraction, and therefore two fractions can be combined. The same as you would do if you had 2 over 3 and 4 over 6, right? You're going to cancel 4 over 6 down to 2 over 3 so that they both have the same denominator. You want the lowest one possible, and then just add the fractions together, okay? So it's the same thing we would do with standard fractions, again, except that we have algebraic terms. Once we've done that, we're going to quickly look at rearranging equations. It's the same as what you did last year in Year 9. It's not really anything new there, just about backtracking, doing the opposite operation in order to get to whatever you want as your subject. So algebraic fractions, let's look at one that's slightly more complicated. So this one is a division. In order to make it a multiplication, as you would with any type of fraction, I flip the last one. So this one's going to get flipped. And I also need to factorize each portion so that it's in brackets, and then we'll start to cancel down. So let's factorize this part here first. So we need to recognize that what we've got there is a difference of 2 squares. But you need to, so let's just look at it separate. So I've got x squared plus 6x plus 9 minus y squared. X squared plus 6x plus 9. Square root of 9 is 3. Square root of x is x. 6x is 2 times 3x, which means I've got a perfect square. So I've got x plus 3 all squared minus y squared. Difference of 2 squares. So I've got x plus 3 minus y, x plus 3 plus y. And I've done that one there. Let's have a look and see what we'll get for the bottom here. So the bottom denominator there of the first fraction, well, there's just going to be a highest common factor there. For this one, there's just going to be a highest common factor. For this one, there's just going to be a highest common factor. So we don't need to actually go through this process for any of the other parts, so that's good. So that's done. So let's now continue. So I've got x plus 3 minus y, x plus 3 plus y over 2, 2x plus 3 for the first fraction. The second fraction, I'm going to flip it, so it's now times, and I'm going to take out the highest common factor of this denominator, which is now the numerator, and that is going to be 5x, and I'll have 2x plus 3, running out of room, over, now, highest common factor of my top there is 2x, so I'm going to take out the 2x, and I've got x plus 3 minus y. Okay, now I look over my numerators and denominators and see if I've got any common. So it can be within a fraction or across the two fractions, because if I got rid of that times sign, technically what I would have on the top would be this whole lot here. and this whole lot here. And that works for our times and divides. So that means I can just start cancelling through without actually getting rid of that times sign. So what I've got here is common is 2x plus 3. So this one here, do I have it anywhere on the other fraction? And by anywhere, I'm actually really looking for the opposite side of the fraction. So I'm looking for numerator. I do. It's here, which means that they cancel out. Something over itself is just 1, so they cancel out. Now we look at the top part of the first fraction, and I'm looking at it and I'm going, well, I've got x plus 3 minus y, x plus 3 plus y. Do I have x plus 3 minus or plus y in the denominator of my second fraction? Yes, I do. Here are my commons. They get taken out. Do I have anything left in common? Well, I've got x and x here. They're going to cancel out. X over x. Imagine there's a times in there. That's a common factor. So x and x are going to cancel. And that's it. So I'm going to end up with, as my answer, 5 times x plus 3 plus y over 4. That's as bad as hard as it gets with multiplication and division. Okay, addition or subtraction. The main thing I need to do is I need to find the lowest common denominator, and then I multiply it through to make sure my fractions are equivalent. So the lowest common denominator is something that 2 and 3 both go into. So 2 times 3 is 6, so it's going to be 6. So therefore, I'm going to have each of these now over 6, and I'm going to multiply the top by whatever I multiply the bottom by. So to get from 2 to 6, I times by 3. So therefore, I've now got 3 times 7x plus 3y. There's a minus in there. And I've got 6, from 3 to 6 is 2. So I'm going to have 2 times 2x minus y. Or negative 2, in fact, because there's a minus there. So then I will multiply through my brackets using our expansion, and I've got everything over 6 now. And once I've multiplied through my brackets, I can go 3 by 7 gives me 21x. 3 by 3 gives me 9y minus 2 times 4, 2 times 2 is 4, so I've got 4x, minus times a minus gives me plus 2y. Don't forget that this minus is attached to this 2, right? So everything is going to be multiplied through. And then I'm going to end up with simplified. I can simplify. So anything that has x can be simplified. So 21 minus 4 gives me 17x. 9 plus 2 gives me 11y all over 6, and that's your final answer. So for algebraic fractions, if you want practice, go to exercise 2.6, or you can do the chapter review or practice test. Okay, so when we're rearranging formulas, all we need to remember to do is backtrack. So how am I going to rearrange my equation for the new subject? Once you've done that, you might have to then substitute values in. So remember, you just substitute in the number wherever the letter was, and you solve it. You also might have to rearrange an equation to solve it. So using our backtracking, but there are numbers and letters within our formula or equation. So let's have a look at a couple of examples just to make sure that we've got it very, very briefly. Okay, so let's rearrange this formula so that R is now the subject. First thing you look at is you look at the thing that is furthest away from what you require and move that, assuming, of course, it's on the same side of the equal sign. So if we're looking at that, then we're looking at the square root of t here, and the square root of t will now be moved up and multiplied, because at the moment it's being divided, so I'll now have the square root of t times s equals 4r squared. Then I'm going to get rid of the next thing, which is the furthest away from r, which is, of course, 4. So divide the square root of t and s by 4 to give me r squared. And the opposite of squaring is, of course, I've just moved this to the other side, is square root. So I've got square root s third t over 4. And that is not quite finished, because you should know that, of course, if I'm square rooting something I don't know, it might be plus or minus. So if you forget to put the plus minus sign in, it doesn't make a big difference when you've only got letters, but when you then put the numbers in, it will give you two different answers, so you need to be careful. If you'd like to review more on rearranging formulas, you can complete exercise 2.7 in the textbook and do the chapter review at the very end of the chapter and do some questions on the practice test. Just remember that you're using inverse operations, or you're transposing numbers and using the opposite of what was done to them originally. So if you're squaring, you're square rooting. If you're multiplying, you're dividing. If you're adding, you're subtracting, etc. And that's it for our revision.